Hey guys, welcome back to the channel. My name is Zahir, and today we'll talk about the white paper that's creating a lot of buzz. The white paper is Agents by Google. I think it was probably published in September, but suddenly has created a lot of buzz in late December and early Jan. And you'll see a lot of interpretations, but I have gone through this particular white paper, and here's the opinion that I have formed. All right, so this looks more like a marketing material for Vertex, and that's absolutely fine, right? Because Google is trying to obviously sell their Vertex AI service, and they would want to make this as easily consumable by a broad spectrum of audience, both technical and non-technical. The white paper could adopt a more platform agnostic approach. So a lot of the examples that you see here are basically based on Vertex AI. Certain feature is something that you'd probably not even have heard of or have seen in different platforms or agentic frameworks. So this is going to be a little centered towards Vertex AI. And there is a concept of extensions, and I will talk about it in a bit, that could have been explained in greater detail, meaning I thought that was a little too abstract because I've seen similar implementations and I've seen that for over a year now. That's not something new or something that I expected, but maybe there's value to it which I'm not able to see at this point in time, and maybe better documentation would have helped. All right, with that, let's get started. So let's see how the agent or essentially the white paper is defining what an agent is. So I have the white paper open. Let me actually go back. Yeah, this is the white paper, and the first section is what is an agent, but I've created a simple slide for to understand that particular definition. Um, so how Google defines an agent is essentially an application that attempts to achieve a goal by observing the world and acting upon it using the tool that it has at its disposal. Now, this is a simple yet powerful definition, perfectly uh, that perfectly captures the essence of an agent, right? And I've seen a lot of experts on LinkedIn and on their YouTube channels. They tend to add layers of complexity with terms like reasoning, context awareness, and so on. Those are the expected feature, but if if somebody asks me what an agent is, I think this is a good definition. This definition keeps things refreshingly, straightforward. But that said, my personal favorite comes from Hugging Face. I believe that this is probably one of the most discrete, straightforward explanation or definition of an agent. And Hugging Face says that AI agents are programs where LLM outputs control the workflows. And we'll see with some examples that I have written previously on what this actually means, right? Um, we'll move on to the next section now. In the white paper, the white paper also talks about the agentic architecture. And if you have been following my channel, this is something that I had actually spoken about maybe almost 6 months ago. And let me just actually play that for you. Yeah, so this particular architecture is something that I had seen in one of a technical sessions in Bangalore, and I had this just stuck with me. I thought this was a very simple illustration of what an agent architecture should look like, at least the agentic runtime. And they have essentially elaborated on that. So earlier, they would call that as a reasoning loop, but it's essentially they're calling it now the orchestration layer. But let's quickly talk about an agentic architecture or an agent architecture at a high level. It's essentially built around three primary components: the model, the tools, and the orchestration layer, or the orchestration essentially. I'd still like to call this reasoning loop because essentially that is what it does. The model at the core of an AI agent essentially lies a language model. This serves as the foundation for the agent's intelligence and capabilities. It is trained on extensive data. You guys know how language models work today. It provides the knowledge, language comprehension ability, process complex instructions. Essentially, use also in the orchestration layer, uh, the capabilities of the model is what is the life of the orchestration layer, right? It basically helps in determining what should the next action or next steps be in a workflow. Uh, Tools, and let me go back to the definition and talk about the importance of tools. And this is what maybe an agentic framework essentially differentiates a simple LLM call, right? And if you look at this, an application that attempts to achieve a goal by observing the world and acting upon its using the tools that it has at its disposal. So tool form the one of the primary components of an agent architecture, right? And simple, right? Because we know that or LLMs essentially can't um, talk to external systems or external environment themselves, and they're obviously not current. They don't have current information, and for you to essentially use that or add that capability to a language model, you'll have to essentially use that in the setting of an agent. And agent systems, a lot of the frameworks today that we see, which is essentially Crew AI, LangChain, or LangGraph, they make very good utilization of tools or have simplified the utilization of tools to augment the performance of an agentic system, right? The last part is the orchestration layer. It is essentially used to reason, plan, and help take next actions or steps in executing a specific workflow. This is the orchestration. This is the orchestration layer, the reasoning loop. It's an iterative process. It's a loop essentially that governs how the agent gathers information, plans, makes decisions, and executes action. All right. Let's move on to the next part in the white paper. Now, this is something was probably my biggest takeaway, right? And this is something that I was excited about because I wanted to see a different approach on how to essentially leverage tools and augment the performance of an LLM or essentially the performance of an AI system to execute the tasks of a workflow efficiently, right? So Google has defined three types of tools: extensions, functions, and data stores. And we'll be talking about extensions and functions. Now, I want to quickly go back to one of the examples that I had created previously, and this is it. I'm hoping that you are able to see the fonts. Let me increase the size to 150. Yeah, this is it. Now, this is a very simple Python implementation. I'm sorry, agentic implementation that I had written. It doesn't use any of the agentic frameworks that LangChain, CrewAI, or anything. This is something that I've written custom so that it becomes easier for anybody to understand how this works. I want to first establish the premise of tools, right? And let me quickly show you the tools that I had created and essentially added it to the agent class, that the framework that I had created, right? We had established tools as basically an abstract class, and then essentially created instances of that, basically inherited the abstract class and created multiple tools out of that, because we want the methods and the signatures of the method to be exactly the same when we are dealing with multiple tools. So the tool class essentially has the name. We want to obviously give the name of the tool so that when an agent or an LLM decides which tool is required to execute a specific tasks, it becomes easier for us to essentially uh, take that name and then use the relevant tool and execute that task, right? Now, description, this is probably the most important method here, because this tells the LLM essentially, or gives the context to the LLM, that this is what the tool is capable of doing, and for specific scenarios use this particular tool and essentially execute the task that the agent intends to execute, or the customer or user intends to execute, right? Now let me actually go back to the agent class and show you how it is added. We essentially have a constructor here that takes in a list of tools, and once we instantiate or create an instance of this particular agent, we simply have to add those tools. As simple as that. Now I hope this was clear to you. Now let me go back to the definition of tools by Google, or the different types of tools that Google, has explained in the white paper, and see where does our format of tooling fit in. Because our format of tooling is very similar to maybe some of the frameworks that we see, which is LangChain or Crew AI, right? Where you don't explicitly mention the input and the output type for a specific tool, and yet the LLM is able to essentially create the payload that it should for a specific tool without having the configuration explicitly mentioned, right? So I think it is in sync with the concept called extensions. Now, extensions are elegant way to bridge the gap between, and this is something that is written in the white paper. Extensions are elegant way to bridge the gap between APIs and agents in a standardized manner. And it enables seamless API execution regardless of the underlying implementation. So imagine you're building an agent to help users book flights, or to check the weather of a specific city. You decide to use either the Google Flights API or maybe the Weather API, any open source API that is available, by connecting your agent to that API. Connecting that agent to that particular API isn't going to be straightforward, right? So you need to essentially think of writing either custom code to parse your queries that extracts relevant data. For instance, if a user says, I want to book a flight from Austin to Zurich, the code would need to identify Austin and Zurich as key entities for that particular method, and um, and there could be some ambiguity in the query, right? Like, what if the user says, I want to book a flight to Zurich without specifying a departure city? This would result in a failed API call because you only have one entity here, which is basically Zurich, and not the schedule or the flight, the time of the flight, the time for booking, essentially. This will result in a failed API call. So essentially, uh, you need to think of another sort of interface where all of this information is gathered first, and then you interface or interact with an API, right? So um, this would basically mean that extensions offer a more resilient solution. At least this is what the white paper says, and this is a concept that we haven't seen. You teach the agent how to use the API through examples. That's the premise there. And if you see here, you're telling that uh, you're telling the agent to essentially get flights method can be used to get the latest. If there is a get flights method that is already written, when the user wants to search flights, the input arguments for that particular flights are whatever the argument 1 and 2 are, example, right? You can explicitly like that, something similar to what we have written. I'll go back to that particular prompt now, or the tool definition. I'm specifying provides the in the time tool, or let me actually go to the weather tool, because um, no, I think time tool makes sense because it's not very explicit here. Time tool, the weather tool is very simple. The time tool, essentially, in the time tool, we are asking the time tool to provide the current time for a given city's time zone, like Asia, Kolkata, America, New York, etc. And if no time zone is provided, it returns the local time. Meaning, uh, we want, when an LLM, has access to this particular tool. Remember, the user might not always give the time zone here, right? The user will always give you only the location. Let me actually run this and show you what I mean by that. I've already run this, but in the interest of this particular demo, I'm going to run it again. Oh, sorry, I need to run all the cells. Yeah, so now the agent is running. I'm going to ask it, what is temperature in Bengaluru? Bengaluru is my city. And remember, I'm asking this question, so the LLM has figured out, in this case, an agent has figured out that the that it needs to use, because it's asking for a temperature of a specific city, it needs to use the weather tool. It has identified the tool, and it has also identified the argument here. And we've actually got the response, but let me actually show you that the weather tool actually, oh, I think I ran the weather tool. I'm sorry. The weather tool is a very simple example. Let me actually go back. Um, I'm just going to say what is the time. Now here's the interesting part, and this is where the orchestration part comes in, right? So okay, so I have asked the time in my city, Bengaluru, which is part of the Asia and Kolkata time zone. Remember, I'm not explicitly asking for or I'm not explicitly passing the time zone here. This is what the LLM has figured out. The reason is because the prompt explicitly mentions, or the description of the tool explicitly mentions, that provides the current time zone for a given city's time, current time for a given city's time zone like Asia, Kolkata, and America, New York, etc. So I'm explicitly telling that this particular tool takes in an argument of a time zone and not a city. Okay, I'm not even telling that it doesn't take a city. I'm just telling that it takes time zone. So the LLM has figured out that when it gets a city, it needs to essentially uh, you know identify the time zone first, and it uses its world knowledge to essentially do that, and we get that information. Now imagine that there was an absolutely new city created in India, and it the base model doesn't have the knowledge of that, right? So maybe it will get that wrong. So let me actually try with something, and this is what is the temperature in Yelahanka. Yelahanka is probably a small, or actually big area in Bangalore, and let's see what it does. Okay, Yelahanka, I think it was able to figure out because I sent it with an API. Now, what is time in Yelahanka? Oh, wow. So it has actually figured out. Okay, obviously Yelahanka is not a new place. I thought this is going to be a challenging one, but I think it's trained on that particular knowledge. But I want to drive the point here is let me go back to the PPT. The point that I want to drive here is that extensions essentially uh, you handle ambiguity by giving it giving the agent a lot of examples to interact with the flights API, so that it has all the arguments essentially that is required to talk to the particular API and get the information from that. That's all there is to it. But if you look at this, you'll probably think that functions also do something similar, right? Um, and if you remember the OpenAI function, let me actually go there. I have the window open. The OpenAI function also used to do something similar, and we didn't even call it an agent back then. We would basically call it a tool, and OpenAI had the capability of talking to that particular tool. And all you need to do is basically define the tool, and there was a format on how you had to define it. You essentially had to create a config file, which was basically the name and the type of the parameter uh, uh, that particular method would take in. How different is this versus the tool that we created? Here you're creating this explicitly. And that's exactly what the functions, is uh, Google talks about in the functions, right? And basically what it says is that in software development, functions are reusable modules of code designed to perform specific tasks. Now, developer define the logic for when to call a particular function, what input it requires, and the expected outputs. In the world of agents, functions operate similarly, but the decision making is handed over to the model, right? Uh, the model essentially uses a set of predefined functions, the example that we just saw, determining which function to invoke and with what arguments on its specifications. Unlike extensions, functions don't directly make API calls instead. So I think the biggest difference here that Google says is um when an API call needs to be made, and if there are any security or authentication reasons that the LLM shouldn't or cannot make that call directly, even the extensions can't come into picture here. You basically give the control back to a client, that the client could be a front-end application or a middleware, and depending on the constraints, the operational constraints, you essentially execute that. What essentially functions allow you to do is you decouple an API execution from the agent. Developers gain the fine-grained control over the flow of data and can iterate on agent development without deploying new infrastructure. Let me actually show you the sample code that Google has shared in the white paper, and we'll talk about it. Yeah, let me start with the extension example. So this is what the example that they've given. They've actually created, uh, you know, a class called extension, and I need to see this in detail. And that class has two examples only today. I think it has, search and code interpreter, and these are the only two extensions that are available. You can also add custom extensions, but this is the example. So this looks more like Vertex API or Vertex AI is offering, right? Let's look at function as well. Um, yeah, so in function, just like we saw with um, the OpenAI function calling feature, you have a function call that you can essentially set it up like this, right? So if I show you an example, so display city is the method that is written, and let's see how this is added to the code. So in the code, again, using the Vertex AI example, so we are importing generative AI model, tool, and function declaration, and within uh, when we are declaring the function, we're adding the display cities function there, and we're also adding function arguments here. If you see preferences, keying cities, I think that auto generate messages tool, print function name, function cities, arguments. Yeah, so we are giving it. I like to take a ski trip with the family, but I'm not sure where to go. Auto generate message tools. Let me see what the what's the list of cities based on the user search query and preferences. Okay, display cities, preferences optional. So functions, as you can see, that you have to explicitly add that. I have the documentation open also for extensions. Let's see how that looks like. You can essentially create custom functions here, create and run extensions. You can see that you can essentially create an extension like this. I think create an API specification file. You have to create a open APIs kind of spec to essentially add uh, uh, the extension here. Like I said, so this is not very well defined at this point in time, but I think you get a sense of what it is trying to do here, right? Um, One final observation is, let me go back to this. You know, while the architectural differences between extensions and functions seem subtle, the choice often comes down to control versus convenience. Developers seeking granular control over API interactions will find functions an appealing option. But I think most of the architectures sort of follow the extension framework today. You look at the AWS multi-architecture, you look at Swarm, you look at Crew AI, probably the most popular agent framework today. All of these sort of follow the extension way of enabling tooling, meaning that you don't explicitly write a configuration of a specific tool. You just write the examples in the docstring the way that we have done here. Let me go back to my code base. Yeah, so you essentially you can write that as a docstring. I've written that as docstring for Crew AI and others, but here I'm explicitly mentioning the description here. Uh, you can write that as part of the description here, and the LLM is still able to essentially figure that out. And I have also done this for multiple, if you look at some of my videos, I have done the same thing without explicitly mentioning what is the type of uh, input and output for a specific tool in like a configuration. I've just written a docstring for maybe Crew AI or the uh, the Swarm multi-agent framework, and you will see that the agent, in this case the LLM, is able to essentially identify the input, and no matter how complex that particular payload is, and able to execute that. Let me actually show you an example. If you go to my GitHub repo, you'll see that I have created a tool called email workflow automation. I think it's called Agent Crew. You can ignore the name. I think it's come by default. And I want to show you the tools there. I have three tools here: Asana tool, DB tools. Remember, Asana tools, these tools they don't have one single string variable. They take an object as an input. And if you look at how I have basically declared the tool so that Crew or Crew AI framework understands that this is the tool that it needs to leverage, all I'm doing is using a doc string for it to explain. That's all. And this fits in, uh, you know, with the concept of extensions that, you know, Google is trying to essentially convey here, right? You essentially give it multiple examples. In this case, I had given it multiple examples, and it was always able to execute this. And there is a video, you can go check it out. I'm going to put the link in the comment section. You don't need functions. I believe developers, can work with this. And if you write a configuration, maybe like an open API spec, write as part of your docstring, then I think uh, the the LLM will be able to identify and work with the tool, identify the arguments, no matter how complex the structure is. It should be able to do that. I think I'll probably do a video on that in the future. All right, folks, that is what I wanted to share. But let me actually go back to the original slide on, my takeaways here in this particular uh, video or this particular white paper, I'm sorry. And as I said, this looks like a marketing material for Vertex AI. If you see, Google in this particular white paper has given a lot of examples for, uh, you know, essentially how you can use Vertex AI. And goes without saying, they are trying to sell a service. They need to do that, right? They need to make the tool usage and increase adoption by making in these white papers and documentation. So yes, what I was expecting, and something I didn't understand the buzz around, was that if it was meant only for Vertex AI, uh, are there capabilities that you can, you know, essentially extend to other agentic frameworks? As is, you can't, right? Because extension is something that is very native to the Vertex AI SDK, and that's not available in, let's say, Crew AI or other agentic frameworks that we know. Even if you want to use uh, the Gemini API or other LLM offering from Google, uh, I'd still maybe want to use the frameworks that I'm comfortable with, right? The other this white paper missed an opportunity to make this platform agnostic, right? This is a white paper from Google, and with despite you know this particular shortcoming, it has caught on, right? It has explained the architecture really well, and that's an architecture that I'm super aligned with, and I've been, in whatever talks that I'm doing, that's something that I've been, sort of sharing with the world as well. And this is something that I had seen in a Google conference or a Google seminar 6 months ago. The concept of extensions, like I just told you, could have been explained in greater detail. Because this is restricted to, or looks like a feature in Vertex AI, I thought they missed a chance on essentially making this platform agnostic and going or double clicking on specific features on how you can actually write the examples. Uh, or maybe they'll probably do that because I couldn't even find good examples in the Vertex AI documentation. But I think that is open to us on how we want to essentially take the concept and implement it in the use cases that we are trying to solve, right? All right, guys, that's it from me for today. I hope this was useful, and if you've if you found this to be useful, please share it with your network. Please like and subscribe, and I'll see you on the next one. Thank you. Bye.